algebra students, how's it going? I'm Mr. Chew. These videos are designed to help you in algebra. I call them Bear Algebra, named after my 13-year-old peekapoo. Make sure you subscribe to my channel, like this with a thumbs up, share it and forward it to friends, and tell them, hey, Mr. Chew is going to help us in algebra class. So we're going to talk about factoring trinomials. These are the harder ones because there's a number in front of the x squared. In that case, the standard form is ax squared plus bx plus c. So before we can do that, let's just quickly talk about how did you use FOIL to multiply 2, because that's how we check these problems that we're doing. Well, it's not that hard. The F stands for first, the O for outer, the I for inner, and the L for last. So, my first is going to be 4x times 3x my outer is going to be 4x plus 3y times 3y, sorry, multiplying. I like using different colors. The inner is 2x times y. And then my last, it's y times 3y. So, now I can combine this, simplify each multiplication term. 4x times 3x is 12x squared. 4x times 3y is 12xy. Y times 2x is 2xy. And y times 3 is 3y squared. So we say these are like terms, so I can combine them. But in what we're doing now, we don't really need that combined line. We need to get to this line right here. So I'm going to break apart this 14 into 12 plus 2. And that's what using this method does. But it really confuses a lot of students. All right, let me get this out of the way because I'm going to need this room whenever I'm working these. We're going to do 2 challenge problems from when I had an introductory video that some people watch. I asked them to do these 2 challenge problems. So, in the 2 challenge problems, if you're someone that did them, you'll be able to check your answers now. So, in number 1, so here's challenge 1. I have 2x squared plus 5x plus 3. First thing we have to do is we have to recognize that it has to be written in this form. Some number to power of x, variable power of x, plus some number times x at first power plus c, and it is. So I know that my a is going to be the number in front of the x squared, which is 2. And then I'm going to have to find AC, so C is going to be the number added at the end. So 2 times 3 is 6. So I can say that AC equals 2 times 3, so AC equals 6. I need to find AC. B is the number in front of the first power, so B is 5. And then I know that that B ends up being the M plus the N. So the AC is 6, so 6 will equal A times C, which is the same as MN. And then 5 is going to be M plus N will equal 5 whenever I make my table. All right, so let's make the table now. We'll see how that goes. So in my table, I know that A times C is going to equal Mn. So I know M times N is going to equal 6. And over here, I know that B equals the number in front, which is 5. And I know that M plus N has to equal 5. For me to be able to get the two binomials multiplied together, that will give me that trinomial. All right, so what do I do next? Next thing I do is say, okay, how many factors does 6 have? So some students are really good at this. I always challenge students just to write it as a factor tree. So I know that 1 times 6 will give me my 6, and 1 plus 6 does not equal 5, it equals 7. So I know that one doesn't work. I know that 6 is 2 times 3, so I can either write 2 times 3 or 3 times 2, it's the same thing. And when you multiply that, it's 6, and 2 plus 3 equals 5, which means that's what I use. Now you can't go and write the answer right now, you've got to rewrite my 5x so that it's 2x plus 3x. So over here I've got I'll rewrite this, 2x squared plus 2x plus 3x, and look, this and this is the same, plus 3. I factor by grouping, What do they have in common? So what's the GCF? Is x. When you multiply by x, you get 2x squared, 2x. When you multiply x, you get 2x. I can actually take a 2x out, can't I? Because you got to do the GCF. See, that would not have worked. I would have seen why it didn't, and I could have shown you why, but I caught it earlier. The GCF is 2x. And when you multiply by 2x, you get 2x squared, x. When you multiply by 2x to get 2x, 1. Do you have a GCF? Yes, 3. When you multiply by 3 to get 3x, 3. When you multiply by 3 to get 3, 1. That's an X here. You can tell this is my 4th video in a row in a tie. I'm actually getting kind of warm. I went to church today and wore a tie, and then I decided I'm going to do some algebra videos, and this happens to be my 6th one in a row. That's a lot. Now, if you remember, I said I live in Indiana, where we take our basketball seriously, and since Reggie Miller used to hit those threes, and when he hit them, you'd say, boom, baby, here's my boom, baby. Boom, baby. And that's the way I would do it when I was teaching in class. And the students would always laugh because I'd say it so loud, they'd jump up out of their chairs. So if I take this out, divide this out, what's left? 2x. If I take this out, what's left? 3. So I'm saying that is the answer. I'm saying that this equals x plus 1 times 2x plus 3. This is a very important algebra concept. You're going to struggle the rest of algebra if you can't understand this and do it. I want you to be able to do it. Okay? So, how do I check this? I use FOIL. So I do first, x times 2x is 2x squared. I do outer, x times 3 is 3x. I do inner, 1 times 2x is 2x. And I do last, 1 times 3 is 3. When I add these two like terms together, I get the middle, and I've got the other two, which means I'm right. Hopefully you did that one right. If you're somebody that tried it in the earlier video. If not, you can always pause it, see if you can get it now. So that's the two methods you can use to learn how to do these problems. Okay, I'll start it over here, and then I'll end up erasing that when I need room. Okay, so the second challenge problem was 3a squared, so this is challenge 2. 3a squared plus 11a plus 10. And it's going to equal 2 binomials multiplied together, but I don't know what they are. So look in red there. You got to go through the procedures in red. So I have to identify that ax squared plus bx plus c. Well, the a in this form is going to be my 3. Don't confuse it with that variable. We don't care. We just want the power to the second power there. It makes it what's called a quadratic. The b is going to be 11. So I could go up here now and I could say, in this equation, I'll write it over here. I know that a equals 3 from my form. It's the number in front of the square term. B is going to be 11. And C is going to be 10. And I say, okay. To find these, and the more you do this, the more you practice this, you will get faster. I have to make a t-table with all these factors in it. I know that AC is going to equal my MN that I'm going to write in here. It tells me that up here. AC and MN are the same. So A times C is 3 times 10. Right up above it. 3 times 10, which is 30. So I know that that has to be M times N, and it has to be 30. Okay? And then it says B is M plus N over here. I know B is, I look at the number, it's 11. It's right in front of the first term, the first power variable. And I know that's going to be M plus N equals 11. All right, now I just have to go through and try all these. So let's take our 30 and we go 1 times 30. Try that one first. Now, the more you do this, you'll get better at it and you'll eliminate the ones that don't work really fast. 31 is not 11, which means that choice didn't work. Now, I know that 30 can be divided by 2. 2 times 15 is 30, which is what I want. And 2 plus 15 is 17. Is 17 and 11 the same thing? No. I know that one didn't work. Now, we can go on and do 3 times 5 here. Or you could have gone up here and I said I could have done 3 times 10. Whenever you get a little bit better at it, you're going to see the ones that work. Doesn't matter which one you use to me. If you want to try the 3 times a 10 here, we know that's 30. And we know 3 plus 10 is 13, which is not 11. So that one did not work. So now we got to make combinations. And we could do either your 10 times a 3 or your 6 times 5. 6 times 5 multiplied together is 30. And 6 plus 5 is 11. Just so happened the last one was the one that I needed. So now what do? I take this 11a and write it as 6 plus 5 or 5 plus 6. Doesn't matter which way you do it. I normally would write it 5 times 6. And then 5 plus 6. And why do I do that? Because I usually do the lower one first all the time in all the problems I do. Did it make it wrong? No, it just flipped the order of the parentheses. So I'm going to rewrite this blue equation to 3a squared plus 5a plus 6a, because the 5a plus 6a is 11a. I didn't change the value of the equation. And then I say, I'm going to group these first two and these last two together. What's the GCF? A. What do you multiply by a to get 3a squared? 3a. What do you multiply by a to get 5a? 5. I better have a 3a plus 5 over here. That's a hint you get from my boom baby. GCF is 2. When you multiply 2 to get 6a? 3a. When you multiply by 2 to get 10? 5. Looky there. There's boom baby. Standing out. And I'd be sitting there in class and I'd say, boom baby! And they would laugh. Because when you're dealing with 8th graders in an advanced algebra class or 9th and 10th graders in a high school class, it makes them jump up out of their chair if they're falling asleep in class. If I divide this out, what's left? A. If I divide this out, what's left? 2. There's my answer. Now I want to check it in a minute. First, I'm going to write it up here. It's 3a plus 5, and then a plus 2. Now, what would have happened if I would have flipped them around 6 and 5? Then it would have been a plus 2 times 3a plus 5, but it's the same answer. Now let's use our first, outer, inner, last and see if I get my original up here. So I do my first, which is 3a squared. 3a times a is 3a squared. My outer, 3a times 2 is 6a. My inner, 5 times a is 5a. And my last, 5 times 10 is 10. And then look what you have here. Like terms, 6a plus 5a is 11a. Here's my 3a squared. And here's my 10, which means I did it right. All right, hopefully it's getting easier. If it is getting easier, then do me a favor. Subscribe to my YouTube channel right now so that you can hear me say boom baby more. I like to have fun while I'm teaching these hard subjects to people, and I want to make it easy for you. Like my video, give it a thumbs up, share it, forward it to people, tell them Mr. Chu wants to help us learn algebra, because I do. All right, I'm going to erase this and put these 2 more challenge problems up here. And these challenge problems will be available in a link right up here on the top. You can find it in my playlist. And it is the solution to these. And it's called 8.04b in my Bare Algebra. So here they are. I'm challenging you. And these are the first 2 examples I do in that video before I challenge them with the 2 challenge problems we just did. So challenge 1, which will be called example 1 in the next video, 7y squared plus 11y plus 4. Challenge 2, 5y squared plus 13y plus 6. So you can pause it now if you want to work them right now. And then since you have this video up and you don't have to start searching for it, when you hit play again, you'll see those links coming up. And try these 2 problems. I'm Mr. Chu. This is Bare Algebra. We've been factoring the harder trinomials. Tell your friends that you found videos from this guy that says, boom, baby, by the name of Mr. Chu, who wants to help you in algebra. I'll see you in the next video. It's time for me to take his hot tie off. Thank you. Mr. Chu out.